Today, we're delving deep into the natural wonders and catastrophic events that have shaped our planet over millennia. Throughout Earth's history, we've witnessed countless destructive natural phenomena, each a stark reminder of the volatile forces at play in our world. From devastating ice ages to cataclysmic meteor impacts, our planet has endured it all. Approximately 12,000 years ago, the end of the Ice Age marked a pivotal moment for humanity. As glaciers retreated and temperatures rose, humans seized the opportunity to flourish. This period of climate stability allowed civilizations to thrive and spread across the globe, laying the foundation for modern society. However, our safety is never guaranteed. We are part of a natural cycle that includes potential threats such as asteroids, climate change exacerbated by human activity, and the looming possibility of supervolcanic eruptions. Let's zoom in on Yellowstone National Park, home to one of the world's largest supervolcanoes. While the likelihood of an eruption is low, history reminds us that Yellowstone has experienced 3 major eruptions in the past. Recent studies have shown indications of potential future activity, though the probability remains minimal. Nevertheless, the sheer magnitude of Yellowstone's dormant power is enough to capture our imaginations. Imagine a volcanic eruption 50 times more powerful than Krakatoa, ejecting material over 1,000 cubic kilometers and creating a volcanic winter that could last for years. In 2014, a study explored the hypothetical effects of a Yellowstone eruption. The findings paint a grim picture. Initial pyroclastic flows spreading at speeds of up to 300 kilometers per h, blanketing states like Wyoming, Montana, Idaho, and Colorado with over a meter of volcanic ash. The consequences would be dire. Widespread devastation of infrastructure, agricultural collapse due to ash-covered lands, and a global cooling effect leading to reduced sunlight and potential crop failures. The human toll would be catastrophic, with millions of lives at risk from respiratory issues and food shortages. Looking back 74,000 years ago, the eruption of Toba in Indonesia plunged the Earth into a volcanic winter that lasted for 6 years. This event drastically reduced global temperatures and led to a bottleneck in human evolution, where our species' population dwindled to as few as 10,000 individuals. Such events underscore the fragility of our civilization in the face of natural disasters. Even a moderate supervolcanic eruption like Yellowstone could disrupt global ecosystems, economies, and the very fabric of modern life. To understand the potential impact of supervolcanic eruptions, it's crucial to delve into their geological mechanisms. Supervolcanoes differ from typical volcanoes in scale and explosiveness. Instead of forming steep-sided cones like Mount St. Helens or Mount Vesuvius, supervolcanoes erupt explosively, often collapsing into massive calderas. The eruption of a supervolcano begins with the accumulation of enormous reservoirs of magma beneath the Earth's crust. Over time, pressure builds until the magma erupts catastrophically, releasing immense amounts of ash, gases, and lava. The resulting caldera collapse can span hundreds of square kilometers, reshaping entire landscapes. Yellowstone's last major eruption, 640,000 years ago, ejected more than 1,000 cubic kilometers of volcanic material. The ashfall covered much of North America and affected global climate patterns. Understanding these geological processes is essential for predicting and mitigating the impact of future supervolcanic eruptions. Advancements in geological monitoring and scientific research have enabled us to better understand supervolcanic activity. Monitoring networks around supervolcanoes like Yellowstone utilize seismometers, GPS, and satellite data to track ground deformation, seismic activity, and gas emissions. These tools provide early warning signs of potential volcanic unrest, allowing scientists to assess the likelihood of an eruption. While the probability of a supervolcanic eruption at Yellowstone remains low in the near term, ongoing monitoring is essential for safeguarding local communities and ecosystems. Scientists also study ancient volcanic deposits and geological records to reconstruct the frequency and scale of past supervolcanic eruptions. By analyzing volcanic ash layers and minerals, researchers gain insights into historical eruption patterns and their global impacts. One of the most significant consequences of supervolcanic eruptions is their impact on global climate. The eruption of Mount Tambora in 1815, though not a supervolcano, caused the year without a summer in 1816. The massive release of ash and gases into the atmosphere led to global cooling, crop failures, and food shortages across the northern hemisphere. In contrast, supervolcanic eruptions eject vast quantities of sulfur dioxide and aerosols into the stratosphere, where they can remain for years. These aerosols reflect sunlight and lower global temperatures, potentially triggering volcanic winters. The resulting climate changes can disrupt ecosystems, agriculture, and human societies on a global scale. While the likelihood of a supervolcanic eruption in our lifetime is low, preparedness and mitigation strategies are essential. Governments, emergency responders, and scientists collaborate to develop response plans for various volcanic scenarios, including super eruptions. Public education and awareness campaigns inform communities about volcanic hazards and evacuation procedures, building resilient infrastructure such as ash-resistant roofs and improved air filtration systems can mitigate the impact of volcanic ashfall on buildings and human health. International cooperation and early warning systems enable rapid response to volcanic emergencies, minimizing casualties and facilitating recovery efforts. While the challenges posed by supervolcanic eruptions are immense, proactive measures can enhance our resilience to these natural hazards. Supervolcanoes are not unique to Earth. They exist throughout the solar system and beyond. Mars, for example, hosts several large shield volcanoes, including Olympus Mons, the tallest volcano in the solar system. While dormant today, Olympus Mons and its counterparts provide insights into volcanic processes on other planetary bodies. Beyond our solar system, astronomers study volcanic activity on exoplanets to understand planetary evolution and habitability. The discovery of volcanic activity on Io, one of Jupiter's moons, highlights the dynamic nature of volcanic processes in extreme environments. In conclusion, supervolcanoes represent a powerful reminder of Earth's dynamic and unpredictable nature. While rare, these catastrophic events have shaped our planet's history and continue to influence global climate patterns. Understanding supervolcanic eruptions is crucial for protecting lives, safeguarding ecosystems, and building resilient societies. As stewards of Earth, we must respect its natural forces and work together to mitigate the impact of future volcanic disasters. Through scientific research, monitoring, and preparedness efforts, we can enhance our resilience and adaptability in the face of natural hazards. Thank you for joining us on this exploration of supervolcanoes and their profound impact on Earth and beyond. Don't forget to hit that like button, smash subscribe for more jaw-dropping space updates, and join us as we embark on a cosmic journey like never before.